Students, now I will discuss about single phase half control bridge rectifier with R load. Now see, when a pair of thyristors are replaced by uncontrolled devices like diodes in the single phase full wave controlled rectifiers, a single phase half controlled bridge rectifier is formed. Okay, so when a pair of thyristors are replaced by uncontrolled devices, that means diodes in the single phase full wave controlled rectifiers, a single phase half controlled bridge rectifier is formed. There are two different versions of single phase half controlled bridge rectifiers. They are symmetrical and second one is asymmetrical. Now in this slide I will discuss about symmetrical configuration. See, in symmetrical configuration of single phase half controlled bridge rectifier, the cathodes of the two thyristors are at the same potential as shown in the first diagram. That means this one. Okay, so in symmetrical configuration of single phase half controlled bridge rectifier, the cathodes of the two thyristors are at the same potential. Hence, their gates can be connected and only a single gate pulse is required to trigger these SCRs. Its operation principle may be during the positive half cycle of the supply voltage, thyristor T1 and diode D1 are in the forward biased condition. When a gate signal is given to thyristor T1, it starts conducting and the load current flows through the path L T1 P load, then R D1 and last N, as shown in first figure. Okay, so what is the path? When a gate signal is given to thyristor T1, it starts conducting and the load current follows the path L T1 P, then load, then R, then D1. Where is D1? This is D1, D1 and then N. Okay, so this is the path. The load current continues to flow until the thyristor gets communicated by the reversal of source voltage at the instant omega t equal to pi. Okay, now during the negative half cycle of the supply voltage, thyristor T2 and diode D2 are in the forward biased condition. When the thyristor T2 is triggered at an angle, it starts conducting and the load current flows through the path and see this figure. So see, when the thyristor T2 is triggered at an angle, it starts conducting and the load current flows through the path N T2, then P, then load, then D2, then L. Okay. So when the thyristor T2 is triggered, let me clear all these things. So see, when the thyristor T2 is triggered at an angle, then it starts conducting and the load current flows through the path N T2 P load R D2 L. Okay, so from this second figure we observe that the load current direction in this mode is same as that of the load current direction in the previous mode. Previous mode means when T1 is conducting, T1 and D1 is conducting. In both the modes, it is clear that the power flows from source to load. The waveform associated with this single phase half controlled bridge rectifier with R load are shown in this figure. Okay, so this is the waveform of half controlled bridge single phase half controlled bridge rectifier with R load. Okay. Now see working of single phase half controlled bridge rectifier with RL load. Okay. The symmetrical configuration of half controlled bridge rectifier with RL load is shown in this figure. Its operation principle may be during the positive half cycle of supply voltage, T1 and D1 are in the forward biased condition and T2 and D2 are in the reverse biased condition. Okay, so during the positive half cycle of the supply voltage, thyristor T1 and diode D1 are in the forward biased condition and thyristor T2 and diode D2 are in the reverse biased condition. When the thyristor T1 is triggered at an angle omega t equal to alpha, it starts conducting and the load current flows through the path L T1 P, that means this path L T1 P load RL, then D1, then N. Okay. So at the instant omega t equal to pi, T1 does not get turned off due to the presence of load inductance. The load current is continuous as the load inductance is sufficiently large. At the instant omega t equal to pi, D2 gets forward biased and the load current flows through D2 and T1. Supply voltage reverse biases the diode D1 and hence turns it off. Hence the load current freewheels through the path L, then R, D2, T1, P and L during the interval pi to pi plus alpha in each half cycle of the supply voltage. So there is one condition is that T1 gets turned off at some instant which is greater than omega t equal to pi radian. That means beta. The instant at which the SCR gets turned off depends upon the value of load inductance. Now see the negative half cycle. During the negative half cycle of the supply voltage, when a triggering pulse is given to thyristor T2, so see during the negative half cycle of the supply voltage, when a triggering pulse is given to thyristor T2 at a firing angle pi plus alpha, it gets turned on. Diode D2 is in the forward bias condition. Hence the load current flows through the path and T2, P, load D2 and L. This cycle repeats for regular intervals and the associated waveform are this. Okay. Now see asymmetrical configuration of bridge converter with R load. Okay. So see in an asymmetrical configuration of single phase half controlled bridge rectifier, separate triggering circuit are used. Okay, so in an asymmetrical configuration of single phase half controlled bridge rectifier, separate triggering circuit are used. So its circuit diagram is shown here. Okay, so during the positive half cycle of the supply voltage, thyristor T1 and diode D2 are in the forward bias condition. When T1 is triggered at an angle say alpha, its load current follows the path L T1P load R D2N. Okay. Now, during the negative half cycle of the supply voltage, thyristor T2 and diode D1 are in the forward bias condition. During this mode, the thyristor T1 and diode D2 gets commutated. Okay, when a triggering pulse is given at an angle for the thyristor T2, it starts conducting and the load current follows the path N D1 P load, then T2, then L. Okay, so in both condition, that's mean during positive half cycle and during negative half cycle, the current direction is same. Okay. Now see asymmetrical configuration of half controlled bridge rectifier with RL load. Okay. Now see its operation. So during positive half cycle of the supply voltage, thyristor T1 and diode D2 are in the forward biased condition. Whenever SCR T1 is triggered at an angle, current flows through the path L T1P load RL, then D2, then N. Thus T1 and D2 conducts from omega t equal to alpha to pi. Now, during the negative half cycle of the supply voltage, thyristor T2 and diode D1 are in the forward bias condition. When SCR T2 is triggered, current follows the path N D1 P RL load T2 then L. Okay, N D1 P load R T2 then L. Okay. By using diodes D1 and D2, freewheeling action may be provided from the instants 0 to alpha and pi to pi plus alpha in each half cycle of the supply voltage. In this converter, as the conduction period of thyristor and diodes are unequal, the circuit configuration is said to be asymmetrical. The waveform of this circuit is like this. Okay.